All right, in the last video, we went over how to create your first Java program, simply printing out "Hello World" in the runtime area, the console area here. So we're going to take this a little bit further and create variables and primitive variables. And we'll go over what a variable really is. Now, a variable is a name stored to location in the computer's memory. And uh, associated with that variable is a literal. And a literal is a value that is written into the code of a program. So basically, what that definition says is that a literal, and we'll type one out here. So we'll erase this uh, system out hello world here and start something new. And we'll also erase this comment too. And we'll say for instance, we want to declare a variable. Now, when we declare a variable, what we're doing is we're going to tell the program what the data type is, or what type of variable this we're declaring, and then we're to tell the computer or the program what the name of the variable is. So, say we want to declare a integer, which you can look up in your book what exactly defines an integer, and it is basically a number between some obscenely low negative number, negative 2,147,000, etc., to or sorry 2 billion, and to positive 2 billion. Um, that's just telling you that what that just basically means is that you're taking up 4 bytes of information, right? And integers are whole numbers. You should remember that from your basic math courses. But say we're going to use integers for the most part in most of the programs we use here. So what I would say is we'll declare integer, and we'll call that integer num. And so this is a variable declaration here. What we're saying is that this variable num is an integer, and because of that, it will take up 4 bytes of space. Now, early computing, that was a lot of space. That could be a lot of space, and it still very well could be a lot of space if you're dealing with large databases and crunching a lot of numbers. But for now, integers in the programs we're going to be using in this course, it will suffice for 99.9% of the time, um, for what we're going to do. But say, is an issue, then you have other choices to pick from. You can look at those other choices of data types in your book. So integer, we declare the variable integer. We'll declare the variable as an integer, and the name is num. All right, and we want to set that value. Say we want to say num is equal to 8. So 8 is the literal. That's literally what num is equal to. And we're storing 8 into the variable num, which is an integer. Now we can't put down 8.5 because that is a floating point notation number. And we'd have to do is change this int into a double. And double is a floating point notation data type that will allow you to put in a decimal place, right? So 8.5. So with that, we can also use the system out API object to print what this well, actually we'll just go ahead and type in print just like in the book. The value is, and then we'll system out again here. And we'll put in the variable num. And from here, we can go ahead and run this program. And it's right here, it'll say the value is 8.5. And so what the system out method did, or the system out that print line method did, was convert the double data type into a string to then output into the output device, in which this case is the terminal, or sorry, the console area, and then eventually our screen, obviously. So the value is 8.5. It converted the double into a string class like object. Um, we'll go into what exactly strings are and how they are different than data types in a couple lessons from now. But for now, let's look at how we can do what we call string concatenation, or a concatenation operator. Use combine two strings together. So we can say here in let's erase this line, and say the value is, and then we'll add in num, and then we'll add in a different line, 8.5 miles. And that's completely acceptable. And we'll go ahead and run this program as well. Parsing takes a little bit and prints out the value is 8.5. And with that, it's simply, you can think of the plus operator as smushing together two different strings together. In this case, it converted num into from a double data type into a string data type, or a string class like object, and pushed it into this string sandwich, and then combined the three strings and did a system output. And you can do this with any type of data type. So let's say we want to make let's go back to integers. Make num an integer called num1, and then we want to have another integer. And actually, let me show you how you can declare multiple types of data types on the same line. So num1, num2 are all integers, same line, right? And we want to set num1 equal to 8. And then we want to say num2 is equal to 9. And then we say we want to set make a third variable, we call it num3, and we want to say num3 is equal to num1 plus num2. And then we want to shoot out here num3. So what I did here is declare the integer value, the integer data types, num1, num2, and num3, all in the same line. So that's my variable declaration line. And then I added num1 and num2 here together, and the literals 8 is equal to num1, and the literal 9 hard-coded into the program is equal to num2, and added those two numbers together, dumped that value into num3, put it in the system outline, and concatenated the three strings, this num3 is converted from a integer data type into a string data type, and then the three strings are concatenated together to make one line, a complete line. And we'll run the program as it's parsing. It'll print out the value is 17 miles. So that is the long and short of it. Next lesson, we will go over a little bit more as to what the what you can do with the math class, and a few more variables and data types, and also the order operation of if you say num1 plus num2, you have another number that you're multiplying it together, what has the higher order of precedence. And you should remember that from your basic algebra courses, but we'll talk about this in a computer science lens.